Hello students, we are still doing this completely made up example that I made up off the top of my head. Let's finish it. So what did we see? We saw that with this transformation, it was injective, therefore it is surjective, and therefore it is invertible. But we showed it was injective in one way, and then we showed it is injective in another way. Now I want to show it's surjective. I already know it's surjective. I mean, I showed it's injective twice. And injectivity implies surjectivity here because we're finite dimensional. We're in the finite dimensional case. But let's just see. So what I would do is I would set C equals to D. I know that I want 2A to be E. So I'll set A to be E over 2. And I'll set B to be F. Okay? So here's how I'd write this as a proof. I'd say let dx squared plus ex plus f be any element. At the time that I've already defined it, I can just say an element of P2 of R. Squeeze that over there. And I'll just write it. I'll say, hey, I'm going to take T of E over 2 x squared plus, my B is F, Fx plus, and my D is C. So D, or my C is D. Okay, so this is in P2 of R. And then I'll just do it. I'll do the thing. So what does this become? This becomes, and I don't even need to look at what I have at the top of the page either. I could just take the derivative of this plus P of 0 times x squared. So what's the derivative of this? This is going to be Ex plus F plus D times x squared, or dx squared plus Ex plus F. And that's the proof of surjectivity because we got the thing we wanted. So, injectivity implies surjectivity, surjectivity implies injectivity, but we were able to show both, and we were able to show at least some of these in more than one way, so that's a little bit of overkill. But that's an example of finite dimension and how we saw it was surjective, but we knew that without having to do this. Or if I had done this, I wouldn't have had to do the injectivity proofs as well. So yeah, that's a nice little example there that we could do. But we have so much time left that I could use in this video. I feel like we should do another example. So let's make something up and let's try to make it fun. So let's do finite dimensional vector space v equals f2 to the 5th power. Maybe that won't be too annoying. Not too many numbers for me to write. Okay, so I'm going to define a transformation t of x1, x2, x3. That's already too many. What we could do is we could left shift. So I'm going to do x2, x3, x4, x5, and 0. x2, x3, x4, x5, 0. Okay, so we're finite dimensional. I know that if we are injective, we are surjective. If we are surjective, we are injective. And if we are either of those things, we are also invertible. But I don't think that this one is going to make it. But that's still going to be fine. What do I mean by isn't going to make it? I don't think it is injective. I don't think it is surjective. But I know if it's one, it is the other. And I know if it's not one, it must not be the other, right? Because if A implies B, then not B implies not A. And if A is true if and only if B, then not A is true if and only if not B. So if I could show that this is not surjective, I know it's not injective. And look at what I can do right here. I could say no v in f2 of 5 satisfies 0, 0, 0, 0, 1. Boom, it is not surjective. Wait, I forgot the important detail. There, T of V equals 0, 0, 0, 0, 1. Right, there's nothing that goes to this because it travels, this vector travels through the transformation and it always ends up with a 0 in the right spot. So this is not surjective. T is not surjective. But here's what we can do now. I can also say T is not injective. And I know it's not invertible. Because if I know one of them is false, the other two are false as well. So that's a nice thing that we can do with this result. Finite dimensional vector space, if your transformation fails one of the three, it fails all of the three. However, let's take another transformation. Let's do left shift again, but instead of putting nothing in the last slot, I'm going to put x1 in the last slot. Okay, so now all I have to do is show one thing and I show the other. I'm not sure whether I should show injectivity or surjectivity here. They're both kind of short. I'll say this one. For any, I don't want to use x's, I'll say for any z1, z2, z3, z4, z5, we can take I want to get z1, z2, z3, z4, and z5. So what do I want to put here? I want to put, I'm going to left shift. So after the left shift is over, I want this one to go over to the other side. So I go z5, z1, z2, z3, z4. So basically I'd take, and I should have enough room here, I'll say take v equals z5, z1, z2, z3, z4. That's now a proper proof. So I take v equals this, and then I show that t of this, which is our v, is equal to the outcome. So this is a proof of surjectivity, surjective. So I now know that this transformation is both injective and invertible. So those are some examples with the results from this section. And that's it for this video.